Hello. Our lecture today is on section 1.1, graphing linear equations in two variables. So just to break down what we're going to do, we have our objectives. One is standard form of the equation of a line, slope of a line, slope-intercept form of the equation of a line, and vertical and horizontal lines. Now, I might go a bit quickly through these notes, but you have a copy of these and you can always read through them a bit more carefully yourself. So let's begin with the standard form of an equation. Linear equation in two variables. The most basic algebraic definition of a linear equation in two variables will state that it is any equation that can be written in the standard form ax plus by equals c, where a, b, and c are real number coefficients, meaning these guys right here, we're going to be using numbers in the future. But for now, in the general sense, we're going to use letters. For example, 3x plus 2y equals 5 is a linear equation written in the form described. So this is standard form, and we'll be going over different types of ways to graph a linear equation in two variables, or to write a linear equation in two variables. Now, what makes in standard form is that we have our x first, followed by our b term. Lastly, we have a number without a letter equal to. So moving forward, but what if we had something like 1/3 y equals 1 minus 2x? That's not in standard form. We want our x term first, followed by a y term, and then our c term. It's also a linear equation because it can be written in standard form. So all we have to do is, well, we can get rid of the fraction by multiplying both sides of our equation by our denominator, and we can do this because we have an equal sign. So we see that illustrated in red. We multiply both sides by 3. So 3 divided by 3 gives us 1, and then we distribute 3 over, so that we have 3 times negative 2 minus 6x. All right, and we have that here in black. And we want to make sure we also have our x on the other side. So let's go ahead and add 6x to both sides like we have here. Let's move it to the other side. All right, so now we have our y and our x on one side of the equal sign, and on the other side we have just a number. Lastly, you want our x first, so we just rewrite it so that we have 6x plus y equals 3. This is standard form. Now, standard form may look different depending on what we have. So here are some more examples of equations that can be written in the standard form of a linear equation. So the first two are like what we did. And the third one, we only have an x, but it's okay. We can make y a 0 with a 0 coefficient. And same thing for that fourth one. It was like our first example that we did. So how does one recognize a linear equation? It has everything to do with understood exponents of 1 on both variables x and y. So there is not some type of x squared or square root of y. They're just x and y with no variables, nothing done to the exponent. When studying algebra, one will realize that progression of topics will often correspond to changing exponents. And here are some of the equations that we'll see in the future. And they have different exponents that you'll see. Right now, we're working with linear. Graphs of linear equations. So just as the name might suggest, linear equations graph lines. But there's many different characteristics that we might have to, well, that we will explore. We just have to build them up. Moving forward, a two-dimensional graph of an algebraic equation with two variables is simply a picture of all the ordered pairs that satisfy the equation. When graphing lines, one only ever needs 2 points. how we find these points is what composes the different methods of graphing lines. Consider the line x plus y equals 5. At most basic level, this equation is asking for all pairs of numbers that can be added together to get 5. And here we have these ordered pairs that satisfy the equation. And we see these ordered pairs, we plot them on a Cartesian plane to create a line. What should be noticed is that any two of the points in the graph connected together with a single line will give the line that contains all the points. So again, graphing lines only ever needs 2 points. The following list of 3 methods will outline the ways to find 2 points and graph lines. Method 1. Find any 2 ordered pairs. Pick any arbitrary number for x and y, or pick any arbitrary number for y and find x. Which one do you choose? You choose whichever is easiest to work with based on what you're given. Do you have a choice? Let's do example 1. Find 2 ordered pairs for 2x plus 4y equals 12. Alright, well, we can go ahead and pick whatever we want. So the first example says, hey, let's go ahead and just by a random thought, let's let x be 4. Alright, if we let it be 4, then that means wherever we have our x, we're going to replace it with the 4. And when we replace something, make sure you use parentheses, just so you don't make a silly multiplication error. If we replace that 4, we see that these two numbers are being multiplied. So 2 times 4 gives me 8. And then we rewrite our problem. Okay, our goal is to solve for the variable. You'll see that you only have one letter, one variable left over. You want to solve it, isolate it, get it by itself. Alright, to get 4y by itself, I need to move the 8. So let's go ahead and subtract 8 to both sides, which we see highlighted in red. And then we're left with 4y equals 4. To get y by itself, let's divide by 4. Divide by 4. 4 divided by 4 is 1. So we're left with y is equal to 4 over 4, which again is 1. So now we have our point. A point is always made up of x comma y. We chose our x in this case. We said x was 4, and we got an answer that told us that y is 1. Therefore, 4 comma 1 is one ordered pair. Now, as we said, to find our line, I just really need 2. I can find as many as I want, but 2 is the least amount you need. All right, let's go ahead and find 2. Oh, well, let's let y be 2. So we're going to choose it to be 2. All right, we're going to replace our y with 2 using parentheses. So we have 2x, and 4 times 2 is 8, equals 12. Now, same deal, I want to get my variable by itself. So let's go ahead and start off by moving the 8. So we subtract 8 to both sides. We see that highlighted in red. All right, we're left with 4x equals 4. Divide by 2. Divide by 2. 2 divided by 2 is 1. We reached the goal of getting x by itself. And 4 divided by 2 is 2. So I have x equals 2. Remember, a coordinate point is always given as x comma y. So we got an answer of x equals 2. And we chose y to be 2. Therefore, 2 comma 2 is another ordered pair. We can plot them, and that will give us a line. Let's do another method. In the next method, greater care is taken in picking the specific number for x or y. Method 2. Find 2 specific order pairs, namely the intercepts. What are the intercepts? Well, we have our Cartesian plane. It's called many things. Cartesian plane, rectangular coordinate plane, xy axis. The one goes left to right, horizontally is your x-axis. The one that goes up and down is your y-axis. So if we have a line, and if it crosses them along our y-axis or x-axis, those are said to be your intercepts. So we have an x-intercept and a y-intercept. Now there's many ways you can plot a line, right? We can have a line going this way, therefore we have our intercepts there, or maybe this way, our intercepts going there. We can also have the very unfortunate case of where our line crosses the intercepts both at the same time. That specific point 0, 0 is called the origin. And we'll know that's the case when we get an intercept for x being 0 and an intercept for y being 0. All right, talking again about that highlighted portion. Method 2. Find two specific order pairs, namely the intercepts. Use x equals 0 to find the y-intercept. Use y equals 0 to find the x-intercept. Example 1 again. Find the x and y-intercepts for 2x plus 4y equals 12. All right, so this is your steps. You're going to let x be 0 and you're going to let y be 0. Doing this process will give you your intercepts. So if we let x be 0, we replace x with 0 and we're left with getting rid of that value. So we're left with 4y equals 12. Divide both sides by 4. And we're left with y equals 12 divided by 4, 3. So what's our coordinate point? Remember, it's always given as x comma y. We chose x to be 0 and my y is 3. So that's our ordered pair. Next, to find our y-intercept, let's let y be 0. All right, that's gone. It's 0. So we're left with 2x equals 12 divided by 2 divided by 2. We're left with x equals 12 divided by 2. X is equal to 6. So I have 6 comma 0. So we have 2 points, and these special 2 points are our intercepts. This method is much less arbitrary than the first method discussed and results in simple equations to solve. Definitely one of my favorites. All right, so there's an example you can try to find intercepts. Let's go ahead and continue with method 3. Use a point and the slope of this point to use the to find a second point. What is the slope? The slope is simply the measure of the steepness of a line. So think of a hill. It has a certain steepness, right? If a line is going up from left to right, the slope will be a positive number. So it goes like this. Becoming larger as the lines get steeper. If a line is going down from left to right, then it has a negative slope. So it'll be going down this way. Becoming larger, negative as the line gets steeper. In algebraic terms, we use the letter m to symbolize the slope, and we have the following definitions that can be used for different situations. So this is how we define a slope. Using m, we define the steepness as rise over run, and that's very helpful. Think about how things rise. Things rise going up and down, and things you run from left to right. So that helps us move our points around. It's called the vertical change and the horizontal change, and we refer to it as change in y over change in x. For graphing lines, the first definition of slope, m equals rise over run, is often most used. Because of the definition of slope, it is easiest to always consider slope as a fraction. For instance, considering the following values for slope. If we have a slope of m equals negative 1 over 2, it is often easy to consider as negative 1 over 2 or 1 over negative 2. This is a question I often get asked. If the number is negative, the entire number is negative. It doesn't matter if the negative is attached to the side, to the top number, your numerator, to the bottom number, your denominator. It still makes the entire number negative, as long as it's only written once. What if I have a whole number, like our second case, m equals 4? It is often easy to consider it as m equals 4 over 1. You can always make a whole number a fraction by writing the number over 1. If we have -3, like our third case, then I can write it as -3 over 1 or as 3 over -1. If m equals 0, we have 0 over 1. From any one point of a line, the numerator of a slope value describes how many units the line will go up or down, while the denominator of the slope value will describe how many units the line will go left to right. So let's take a look at our examples. If I have -1 over 2, remember, up and down, left to right. If I have a negative, then I know I'm going to go down 1 unit. If I have a positive, then I'm going to go to the right 2. So your rise, -1, down 1 unit, while it runs 2 units right. What if it were the other way around? Remember, it's always rise over run. If I have a positive number for your vertical movement, then I'll move up. In the denominator, I have a negative number for your horizontal movement, so it'll go left. And you have more examples to consider and to look. Note, any line with a slope of 0 will always be a horizontal line. Now that the concept of slope is defined, lines can be drawn by simply knowing one point and using slope to find the second point. Example 3, graph the line through the point -3, 2 and the slope of -4, 9. So we first want to plot the point. First step, our point is -3, 2, and we have this here in red, -3, 2. Now we're going to use our slope to plot another point, our second point. So step 2. Now from this point, we have a rise over run, so I have a -4, let me zoom in, have a -4, so I'll go down 4 units. I have a +9, so I'll go to the right 9 units. We're going to use this movement from our point that we set up. All right, so we have our point, and we said we're going to go down 4, which we see highlighted here, and then we're going to go to the right 9. And that gives us another point. We connect the 2 points, and we have a line. All right, you have another example for you to try. Moving forward, notice these last examples gave a point and a slope, but the examples from earlier were given as equations. So now we define the slope-intercept form equation of the line, which makes for efficient graphing of lines. Slope-intercept form of the equation of a line. Consider the linear equation y equals 3x minus 1. Because y is isolated on one side of the equation, finding 2 points is easily done by picking 2 values. All right, so let's go ahead and pick 2 points for x. If we let x equal 1, we see our work, we get -1. If we let x be 1, we have 3 minus 1, we get 2. So we have our 2 ordered pairs. Let's consider the graph of the equation y equals 3x minus 1. This gives us some important features. Namely, the 3 is your slope, and your last number is your y-intercept. So it's the point along your y-axis, the vertical axis. And we have that written here. Your y-intercept is -1, and your slope is 3. As these numbers in the equation y equals negative, are these numbers of the equation y equals 3x minus 1? This observation leads to a discussion on the second version of the equation of a line. Y equals mx plus b is called the slope-intercept form of the equation of a line. Just like how we had standard form, we're going to add to our list slope-intercept form. Now this is very cool. It tells us our slope and it tells us our y-intercept. So we see that if we let x be 0, we'll only get an ordered pair, which is the y-intercept. And if we let x be 1, we'll get another point. Therefore, if a linear equation is in slope-intercept form, by determining the slope and the y-intercept only requires inspection. Meaning, just like a previous example we did, whereas I was given the slope and the point, I can use my point followed by my slope to create another point. Okay, so graph y equals 1 over 3x minus 2 using the slope and y-intercept. Okay, so let's begin by plotting our y-intercept. In this case, my y-intercept is -2. So that's the point 0, comma, -2. We plot it. That's here. All right, now I want to use my slope. My slope is 1 over 3. Remember, rise over run. I have a positive 1, so I'll go up 1. I have a positive 3, so I'll go up 3. I'm sorry, right 3. So up 1, right 3. So from 0, -2, I'll go up 1, and I'll go to the right 3. And we plot another point. So I go 1, up 1, and then 1, 2, 3. I have a new point. We have graphed using our slope and y-intercept. Example 6. Graph 2x plus y equals -1 using slope and y-intercept. Okay, some work needs to be done. Recall that our equation of slope-intercept form is y equals mx plus b. So how do we reach this form if it's not given in this form? Your instruction is you must solve for y, meaning get y by itself. You see how it's all lonely? Make sure you get it by itself. So example 6. Graph 2x plus y equals -1 using slope and y-intercept. This equation must be put in slope-intercept form. All right, so I want to get y by itself. What's bothering it? This 2, right? 2x. So let's move 2x. If it's being added, in order to move it, I subtract. So since it's positive, I'm going to subtract 2x on both sides. So I'm left with y equals -2x, and I have a -1, so -1. We now have our slope-intercept form. This lets us easily pick out our y-intercept, our y-intercept, which is -1, and our slope, which is -2. Let's write it over 1. All right, so we have a y-intercept of -1, which is right here, 0, comma, -1. And we have a slope of -2 and +1. So I'm going to go down 2 and to the right 1. So I go down 2, 1, 2, and to the right 1, we have a new point. We connect our two dots and we get a line. All right, we have another example. I'll let you do that on your own. Moving forward, horizontal and vertical lines. So in a nutshell, let me tell you what you'll look at. You'll have a vertical line when you get x equals some number. This means you'll have a vertical line at that number. You have a horizontal line when you get x equals some number. I'm sorry, y. Y equals some number. All right, now here's how it explains it. Let's go back to example 9. Graph y equals 3. So we know we have a horizontal line at 3. Now, if you want to write it in slope form, then you would see that you don't have an x value. So it would be a 0x. So therefore, it can be written as y equals 0x plus 3. We have a y-intercept of 3, so we plot that point. And you don't have a slope, meaning you have a slope of 0 over 1. So you don't go up 0, you just move 1 unit to the right. And there you have your points. On a secondary level, the equation y equals 3 can be viewed as saying that regardless of what value is chosen for x, y will always be 3. 2 points for the graph can be found as follows. So you can also do this using a little chart. Remember, our lines are always given as x comma y. Let's do our chart for our x's and for our y's. Now we're saying this is telling us that y is always going to be 3. So for my y's, let's write a 3 down. My x's may change. So let's pick any number we'd like for our x's. To model what we have, let's let x be 0 and let x be 1. So what coordinate points does that give us? This gives us the point 0, 3 and 1, 3. And we plot them, they'll result in our line. Very cool. With either interpretation, the result is a horizontal line with y-intercept at 3. What needs to be recognized is that anytime a question asks for a linear graph in 2 dimensions and there is only a variable y, the equation can be written as y equals a number. The understood slope will be 0 and the graph will be a horizontal line that passes through the y-intercept. Likewise, if an equation asks for a linear graph in 2 dimensions and there is only an x variable, the graph will be a vertical line. So let's take a look at this. Example, x equals -2. All right. So I look at my x-axis, I find -2, and I go ahead and expand a vertical line. Or you can do your chart like before. Our points are always given as x comma y, and our rule says, hey, let x always be -2. Okay, well, I want to pick new points because I need a coordinate point, x comma y. So to match our notes, let's pick let y be 0 and let y be 1. And we see that this gives us a point, -2, 0 and -2, 1. We see that we have these points, we plot them, and we connect them, and we see we get a vertical line. In summary, any linear graph in 2 dimensions that only contains one variable will be a horizontal line if that variable is y, and a vertical line if that variable is x. We will discuss the slope of vertical lines in the next section. All right, I'll start a new video for section 1.2. I know I go pretty quickly, but you can always rewatch a video or pause the video. It's just so that I can go through it with you. All right, if you have any questions, please email me or post them in our general discussion board. Thank you.